Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, this is lesson 8.3.3. It's called Constructing Shapes. And for this lesson, you're going to really want to have this the resource page to print off. And it's also helpful if you've got like really thin paper. Use that. I know a lot of people will like take a piece of paper and they'll trace it by putting it up on glass like a window and using that. Whatever technique you could use for tracing for this particular lesson, that would be really, really good. Now, we have something called tracing paper in the classroom that's really, really thin paper that we use, but obviously that's going to make things a little bit tricky here since you're watching this on a video instead of actually in the classroom. So we're just going to make the best of it. And if the whole tracing of things is a little bit challenging, then just feel free to watch the video and do your best to just draw these shapes in your journal, and we'll try our best to make it work. Okay, so let's go ahead and get started with the intro. It says architects and drafters make careful drawings of buildings that they design. The drawings represent how the building should be constructed. They show the thickness of the walls, where the doors, windows, and pipes will be. To make these precise diagrams, professionals often use special computer software. However, some architects still prefer to draw diagrams by hand, at least some of the time. They use special drawing tools and that look something like those that are drawn on the right. So this is a protractor. That's a square, basically, because you get the right angles here, and then of course a ruler. Building plans are just one example of precise geometric drawing. Mathematicians have used these basic tools to draw accurate diagrams for other reasons. In mathematics, making a construction is the process of using a straight edge and compass to solve a problem or create a geometric design. And in this case, the compass we're talking about is not the north, south, east, west compass, but it's that tool that you use to draw perfect circles. Okay? So in this lesson, constructing shapes that meet different guidelines can help you understand many of the specific characteristics of those shapes. In this lesson, you will use given conditions to construct your own shapes. All right, so without looking at anyone else's work, you obviously can't, you're watching this on a video, so it doesn't really matter. Each member of your team, or just you, should draw a triangle with one angle that measures 60 degrees and one side that is 1.5 centimeters long. Okay, so this is what you can do. This piece of paper that is attached, it's the resource page that's attached to the Google Classroom and in the online book. You can print them off, and then you can trace, this is like the 1.5, and this would be the 60-degree angle. You can trace those and try and work with them, or technically, so you can use a protractor and you can use a ruler to make this work as well. But I am going to take each one of those and I'm going to follow these directions. And what was the direction again? It says create a triangle with one angle that measures 60 degrees and one side that is 1.5 centimeters long. Okay, then it says when each member of your team is finished, check the drawings of your teammates by trading papers and measure the sides and the angles to make sure they did it correctly, right? Does anyone have triangles that match the given description, or does everyone? And if not, come up with a strategy for drawing accurately sized angles and line segments. Okay, so you obviously can't do that. So let's just, how would we go about doing this? Well, here's the angle that I have put in here. And here's one of that side, okay? So we can kind of rotate this guy around all that we want because I've got my computer program. And so what I would do is this. I would just take this side. Come on, seriously? There we go. That's better. And kind of do this thingamajigger here. And then we'd want to have the 60-degree angle go on top of that. And oh my goodness, this isn't going to work very well. This is hard for me too. All right, so this is what I'm going to do. I'm going to take and I'm going to create a line that looks just like this. And I'm going to move this guy on top. So that's the 1.5 centimeters. So I'm going to move it to right here. And if I create I got to create 2 more lines, right? And so the only other criteria is that you've got a 60-degree angle. That's all they're saying. So if I do it like this, I can make this guy go to here, and then this guy goes to there, and that's one of my triangles, right? Boom. Let me get this going a little bit better than that. Yeah, that's okay. Stop it. Okay. So this is going to be one of our triangles right there. So I'm going to group those. I'm going to set that off to the side. All right, now let's try this again. So this would be like the second person in the group, where we've got our segment, which is 1 centimeter long, and I'll go and put this on top right there. And now the second person in the group decides, well, you know what I'm going to do? I'm going to make this guy this long, and then I'm going to finish it as such. And what do we have going on here? We've got yet a different triangle. So right there, I've shown how we can take 2 different triangles that meet the same criteria, where there's a line segment that is 1.5 centimeters long and one angle that is 60 degrees, but there was no criteria for the other angles or the other sides. So are all the triangles the same? If you were doing this in a group of 3 or 4 students, there's a very good chance that they would not be all the same, since I've just done 2 of them and they did not work out to be the same. So this says measure each of the 3 angles in your triangle. What is the sum of the 3 angles? All right, so let me move this guy over here. I'm going to go ahead and get rid of those. They're kind of in my way now. I don't need them anymore. All right, so protractor. Let's come out. Let us take a look at this angle right here. This one appears to be about, well, we knew that one was 60, right? So we know one of them is 60 degrees. I'm going to write this like this. 60 degrees for one of them. And then let's see what this guy measures. This one appears to be about 61 or 62 degrees. Call it 61 degrees. And now for the last angle, let's measure this guy right there, put it on the origin. Let's get this guy lined up with 0. And this one appears to be about 60 degrees. Okay, so I'm actually, does it look about 60 degrees? When you add those up, it adds up to 181 degrees, but I might have made a little bit of a mistake on that. In fact, I think I made this guy too short, and technically, when I measured it, it was supposed to be 60, but it actually measured 59. So really, when I measure all 3 of them, they add up to 180 degrees. All right, so let's take this guy. And remember, that was the 60 degree right here. So let's see what this one is and what that one is. So for this one, this appears to be about 100 degrees. And let's see what that last angle measure appears to be. What am I doing? I'm confused. All right, there we go. We're going to put that guy right there. And now that's what we want to do. Let's see what is that up here to measure? Well, that's about, move it a little this way a little bit. Okay, I did not do a perfect job with these triangles. That's about 20 degrees or 21, 22 degrees. Come on, get out of there. Okay. So this 21 degrees. And so that adds up to 181 degrees. What we are noticing is this. Of course, there's some measurement precision. It's not really easy to get the perfect measurement. And of course, you can see this triangle is not set up perfectly, nor was this one. But, you know, for the most part, they are adding up to about 180 degrees. And so there is a theorem that's called the angle sum theorem of triangles that tells us that anytime you take a triangle and you measure the 3 degrees of the triangle, the total sum is going to be 180 degrees. That is if your triangle is made perfectly and you measure appropriately. And I did a little bit of the measuring appropriately, but I did not make perfect triangles. But This is the big idea right here. All triangles have a total sum of 180 degrees when you add up all three angles of that triangle. There are other proofs that we could use too, and we'll get more into that in 8th grade. Chapter 9 of 8th grade, we'll get deeper into this idea of the triangle sum theorem. All right, what does this one say? It says, again, without looking at each other's papers, have each member of your team draw a quadrilateral. Quadrilateral means a four-sided figure with one angle that's 30 degrees, one angle is 60 degrees, and then one side will be 5 centimeters long. All right, so let's give this one a shot. Do I have this guy locked in there? Let's lock that in. All right, so I'm going to start with my line, which is going to be 5 centimeters long. So let's go ahead and do this, 5 centimeters long. And then we need an Then we need an angle that's going to be a 30-degree angle and a 60-degree angle. So I'm just going to take these guys and put them together as such. How's that work? Is that pretty good? So it doesn't tell us how long this line has to be, but they do want it to be quadrilateral. So I'm not going to come all the way up here and make a triangle. I'm going to leave it like right here. And this guy is a 30-degree angle, so I'm going to do this as such. And then maybe I'll make a trapezoid out of it. How's that sound? Yeah, we'll call that a trapezoid. So, does that look everything okay? Maybe I need to shorten this guy just a little bit. Did I get that right down here? Stop it. It's very hard to get this perfect. Almost easier not using this program. All right, there is one of our shapes. Now let's try it again. Start with a 5 centimeter line. Stop it. That's what I want right there. Okay, and this time we've got your 30-degree angle that's going to come out of this one. You've got your 60-degree angle that's going to come out of this one. And I have no restrictions on how long this one needs to be, so maybe I'll just go to here. For this one, maybe I'll go to here, and then we'll connect those as such. So now, I've got this as my quadrilateral. All right, so I've met the requirements with both of them. I've got 5 centimeter sides. I've got 2 angles, one's 30 degrees on the bottom right, one's 60 degrees in the bottom left, but there were no restrictions on this angle or that angle, and there were no restrictions on the other 2 side lengths, 3 side lengths, 1, 2, 3. So what eventually happened was we ended up getting different shaped quadrilaterals. Okay, so are all of them the same? No, they are not. Now measure all of the angles of quadrilaterals. All right, so let me go ahead and get rid of these guys and pull up my measuring protractor. Take this guy first. And we know this is 60 degrees, right? And we know this one was 30 degrees. So the other 2, what are those going to be? Let's put it on here and rotate. Does that appear to be about that's obtuse, so it's going to be about 124 degrees, somewhere around there. And what is this guy? This is another obtuse. So that one looks like it's about 140 degrees. What do those add up to? 124 plus 140 plus 60 plus 30. I don't think this is right. I made a mistake in something. I'm going to go check it again. So this adds up to 354 degrees. It's actually supposed to add up to 360 degrees. So it wouldn't surprise me if I've got some of these angles a little bit wrong. Let's check and see if I messed up on my 60 and 30 degree angles. Yeah, that's not quite 60. That one looks more like it's about 58. What does this one measure? That one, what is that? It's not even 30 degrees. That's like 42. I'm so confused here. Why those? I followed those angle measures. I bet they're not even right. So what was that? About 58? That was about 41 or 42. Call it 40 degrees. So now what do they add up to? That is 12. This is a 1, so it's 9, 10, 60. That carry the 1. All right, that's closer to it. Once again, my precision and my measurement and my creating of these shapes made it a little bit off. But this is the key right there, is whenever you have a quadrilateral, which is a four-sided polygon, stop it, you are always going to have all of the angles are supposed to add up if they've been constructed properly, 360 degrees. Okay, so the sum of the angles in a quadrilateral is always going to be 360 degrees. Now, here's something that's kind of interesting. Quadrilaterals, if you were to cut them in half by going from one vertex to another vertex through the shape, you would create two triangles. And what we learned in the previous situation is each triangle has a total sum of the angles as 180 degrees. So when you can create two triangles, that means you're going to get a total, this angle plus 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 this angle is going to give you a total of 360 degrees if they've been properly created and properly measured, which mine was not done perfectly. Which brings me to something that I find, once again, really interesting about these geometric shapes with all these polygons. If every single triangle has a total number of degrees of the angles as 180 degrees, if you have a quadrilateral, that's two triangles, that's going to add up to 360 degrees. If you have a pentagon, you can create 1, 2, 3 triangles in there by starting at a single vertex and then drawing diagonals across that shape. Well, if you were to add up all of these angles, guess what they're going to add up to? 3 times 180, which is 540. If I take another shape, let's take another shape in here. Where are you, other shape? How about a hexagon? How many triangles can you get out of a hexagon? Well, let's start here. You can get 1, 2, 3, a total of 4 of them. So each one of these would be 180 degrees. 4 times 180 is 720 degrees. So the total sum of all the angles in any hexagon is going to be 720 degrees, and so on and so forth. There's a little formula for that, but we don't need to worry about what the formula is. But it's just something to be aware of. Now, let's go back here. If we were to just take, hold on. If I were to take this right here and draw it straight across, then I would get two trapezoids, correct? And we know that these are quadrilaterals, and we've already determined that those would be 360 degrees, right? So this is 360, this is 360. When you add those together, you also get 720 degrees. So a little bit of information now about triangles and quadrilaterals. I'm sorry that our experience of constructing these quadrilaterals and triangles wasn't a little bit easier. To be honest with you, even when we're in class, it's not the most easy activity to do. So you get the general idea. The major point of this is triangles, all polygons, quadrilaterals, they're all made up of sides and of angles. And what we're going toward is, if you know enough of the sides or angle measures, you can figure out other parts of the triangle and quadrilaterals. So I think that ends it for today. How much time did we take on this? Not too bad, a little bit less than 20 minutes. All right, let's move on to the next activity. Take care. Bye.
Hey, feeling good.